Hello and welcome to the Hertford Astronomy Group. It's lovely to see you all here for the start of another academic year's worth of meetings and events. Lovely to see some new faces there, new names on the list, and special welcome to you. And we hope that at the end of the meeting, perhaps you can stay around and have a little chat with us, introduce yourselves and tell us your interests in astronomy. During the meeting, usual requests, please, if you could make sure that you keep your microphones on mute, try and avoid touching the space bar on the computer, which accidentally turns your speakers back on. The format for the evening is that Martin Weston is going to give us a short talk about the night sky, and then we're going to pass over to Jerry, who's going to introduce tonight's guest speaker, who is well known to many of us in the club, because he is basically the father of the Hertford Astronomy Group. After Roger has given his talk, Jerry will take questions. So if you've got questions, could you please submit them using the chat facility? Just type your questions in there and Jerry will see them and he will put them to Roger. After that, I'll wind up the meeting. Just to give you a little reminder, by the way, if it's clear, you might want to pop outside and catch the lunar occultation of Uranus. It starts at 20:41 and finishes at 11 minutes past midnight. So you've got a couple of minutes, nip out there, get your telescopes all set up and a chance to see it, or at least the reappearance later on tonight. So I will wind up the meeting at the end. We would hope that to finish at about 9:30 for the main meeting. When we've concluded that, by all means, please stay on and have a little chat amongst yourselves like we were doing at the beginning. And we will terminate the meeting at 10 o'clock so we can catch up with today's latest events. So no more from me. I'm going to hand you over to Martin, who's going to tell you and show you some lovely photos of things that have been happening. So over to you, Martin.
Okay, as Alan mentioned, we've got an occultation, Uranus and the moon. So I'm just on stellarium at the moment, so can't see anything at the moment. It's probably a bit too early, but that's where we're looking, and that's due east at the moment. But while we've got this up on the screen, I just want to show you currently we've got a few planets that can be observed. So between northeast and east, we've got Mars here, and the moon just slightly, Mars in Taurus, the moon's in between three of the star constellations there. And then you've got Jupiter, which is very bright at the moment. I'll talk a little bit about Jupiter later. And then as we come round, we've got Saturn here in Capricorn. So there's plenty of planets to be looking at. That's almost just past the south point at the moment. A bit early for the winter constellations, not coming up yet. So the planets is a good thing to be looking at the moment. So definitely if you can get out and have a look at the moon and see if you can see the occultation of Uranus, that would be something quite spectacular. I'm sure there'll be lots of pictures. Zooming up, I can't see anything at the moment. It's probably just too early. So I'm going to switch now. Go to my presentation. Hopefully you can all see that.
Yes, we're okay.
Okay.
Yep.
See that, yeah?
Yes.
So that's what I was just showing earlier on stellarium. So talking about Jupiter, thought I'd show this picture. This is a picture of Jupiter by Damien Peach, who has been visited our association several times and given us talks on the planets, especially on Jupiter, because it's something he specialises in. But he's a world-renowned astrophotographer, especially on planetary, and comets are his main thing. But that image was taken quite recently. It was taken on the 11th September. So the next little bit of snippet I found that I thought was quite interesting was how big is the universe? It's interesting to see how our knowledge has improved over the period. There we on that image on the side, you can see the known universe in 1922, which was believed to be 100,000 light years, probably just about the size of our galaxy. And now we're looking at the known universe to be 93 billion light years. And there's a little bit of spurb there about how they come to that calculation. So it's one of the fundamental questions of astronomy by looking for the first observable point from the Earth. In this particular case, we're looking at spots at 13.8 billion light years away at the time of the Big Bang. And obviously the universe has been expanding over the lifetime of that, when that light left and come to us. And if the inflation occurred at a constant rate, the same spot is now 46 billion light years away. So we'll double that up, obviously, making the observable universe 92 billion light years. So quite a large area. Next, talking about the progress of Artemis 1. Obviously, it was cancelled due to technical issues. This, of course, is the latest moon mission. This is actually an unmanned mission where we're going to put a rocket into space and then send another unit off to the moon to go round and then come back again, just to test out the operational needs for the actual missions, which will be manned later on as we go back to the moon after 50 odd years. So that's the update. So next launch for the Artemis 1, first integrated flight test of the Space Launch System rocket and Orion spacecraft beyond the moon. So they're looking at a demonstration test on 21st of September and then a launch opportunity on the 27th and with a backup opportunity on the 2nd of October. So that'd be interesting to see that. Next one is, and we've talked about James, well, I've talked about the James Webb Telescope. We've looked at some of the images in the past. Well, this is quite a fascinating one. It's an image taken by the James Webb of an Einstein ring. Now, an Einstein ring basically is where light is being bent around the mass of something with a lot of with a high gravity field. So this particular one here is a distant galaxy passing through warp space, time surrounding the galaxy of another galaxy. They just happen to be perfectly in line. So from our point of view, we're looking at the ring is actually the second galaxy behind the galaxy that we can see in the center of that ring. So this is an interesting, we talk about neutron stars. We talked about black holes earlier on. The neutron stars are the remnants of a supernova. And what actually happens, the core collapses and the atoms are packed so tight together that the normal matter is so compressed that things start to change slightly. So I'll go into a bit more detail. So I'll just read this little section here. So the star, a massive star, it ends up the size of a city, and all the matter that was in there is compressed into very tight spaces. And neutrons, that's why it's called a neutron star, because neutrons are free from the atomic structure. And just to help a little bit, I've downloaded this, which is the core, which is a breakdown of the core of a neutron star. It's so dense that physicists aren't sure what happens inside. It's saying here, researchers can't recreate the conditions in the lab. And in the event of the theory, nuclear matter is of limited help. So this is what they believe is in the center. So we're talking an atmosphere on the outside of the lighter elements, such as hydrogen, helium, highly compressed, obviously, outer crust of the heavier elements, such as iron, inner crust packed as a lattice. The outer core, neutron-rich ions in a sea of free neutrons. And the inner core, tightly packed nucleons and quarks intact. So again, this is theoretical, but interesting about discovering these neutron stars. This in 2019, NASA Neutron Star Interior Composition Explorer, or NISA, an X-ray telescope installed on the International Space Station 2 years prior, measured the size of a 1.4 solar mass neutron star, which is 1,000 light years from Earth. And it's just 26 kilometers across. So if you can imagine the volume twice that of our sun compressed into an area the size of a city, a small city. And now NISA data to have independent teams have performed a similar analysis on a neutron star located 3,000 light years away. Okay, so really I'm wanting to just show you some of the images that have been taken over the summer break to give you an idea what some of our astrophotographers have been doing. So this first one here is by one of our members, Kevin, who's taken this fantastic picture of the Elephant's Trunk Nebula. So cool because this section in the middle here looks like an elephant's trunk. So I'll just read what Kevin's put. The Elephant Trunk Nebula is a dense region of dust and gas found within the considerably large star-forming region IC 1396 in Cephus constellation, designated IC 1396A. Elongated globule of dust and gas was named the elephant's trunk because it resembles an elephant's head and trunk at visible wavelengths. So these were taken back in May over several nights. Nice picture, Kevin. Thank you for that. Another one by Kevin is the Bubble Nebula. That bubble is actually 7 light years across, which is quite amazing, really. It's 71,000 light years from Earth in the constellation of Cassiope. And it's another star-forming nebula, 45 tons more massive than our sun. Another one by Kevin. This is of the Wisdom Nebula. I think Kevin uses Hubble palette for this. That just means that the way that we do photography with mono cameras, we use filters, hydrogen alpha, oxygen 3 and sulfur 2. And depending which one of these colors we allocate to the filter gives us the palette. So this with the Hubble palette, the sulfur is used for the red. Green is taken by hydrogen alpha, and blue is with oxygen, and that's tends to bring out the image quite nicely. That's another fantastic picture. Now a picture of our sun from Steve. These were taken a couple of weeks ago, I think, but again showing the high solar activity we've got the sun at the moment. These images showing some fantastic prominences and some sunspots as well. Again, Steve takes these from his back garden. Another one by Steve. So he's done, we spoke about Jupiter and Saturn. So these are images that he's taken on the 21st of August. I think they're quite good. Another one by Steve is the Whirlpool Galaxy. This is 2 galaxies interacting with each other. One galaxy is pulling the material from the other galaxy by gravity. It's called the Whirlpool because it looks obviously a little bit like a whirlpool. So it's 27 million light years away. And this was, had some problems with the weather at the time, and it was a bit overcast and thin cloud layer. So, but still, I think a pretty good picture. You see Drew is taking it from the London suburb. This is one of mine. This is a supernova remnant in Cygnus, the Swan. this is part of the supernova remnant, which is called the Val Nebula. And it's the eastern part. If you look in the sky, it's the eastern part of the nebula. It's quite a large area of space. It's if you put several moons in between the area that this occupies. This is the western side of the Val. I've just taken quite a close-up section. That star is actually in front of the the nebula, but it's lighting it up beautifully. You can see the colours. Again, I've used the Hubble palette on that. This one you may recognise from pictures many years ago of the pillars of creation that Hubble took and was so spectacular. It's a part of the Eagle Nebula, and these are the pillars here. Not quite as good as the Hubble image, but you can definitely see the pillars here. And this is a star forming area. I've actually removed the stars just to show a bit more definition. Again, it stretches about 4 to 5 light years across. But the whole nebula is 70 to 55 light years across. And that's it. So I don't know if there's no questions. I'll pass it back to Alan.
Do we have any questions for Martin though?
No, I just have a comment that first of all, your first picture, for example, of the Veil Nebula, often the Veil Nebula just comes out pretty much all one color, and you've got a fantastic range there. It makes it look so much better. And I should mention generally that some of those images from Martin, Kevin, and Steve were ones which I used in producing a new poster sheet for our display boards. So on Saturday we had our publicity event at the Howard Centre, and I had updated 4 out of the 6 display boards and put together what I think, Martin, you'll agree, is a nice colourful collection of images from some of our members. And I really must also thank Martin and Tony and Steve for coming along on the day to help out with that.
Okay, thank you very much there, Jerry, for passing on those plaudits to the people who contributed there, and particularly to Martin for putting it all together. And like Jerry said, you know, thanks to the team who worked down at the Howard Centre on Saturday. I'm now going to hand you back over to Jerry, who's going to introduce our speaker, who doesn't really need an introduction, but as some of you are new, perhaps we will learn about him. So over to you, Jerry.
Thanks very much, Alan. So for those of you who know me will know of my, I was going to say, deep interest in exploring the moon. Obsession might be more appropriate. I mean, I watched the original moon landings back in the 60s, and my first talk about space was about that. One of the science teachers at school said to me one day, "Look, we're all interested in the moon flights, and you know more about it than we do. Could you do a talk?" And so that was my first one over 50 years ago. And then we watched the remainder of the Apollo missions, and the last time we went to the moon was 1972. And for the last few years, I've been giving a series of presentations at the British Interplanetary Society on the 50th anniversary of each of the missions. And back then, nobody dreamed that it would be more than 50 years before we returned. But now we're working on that. And so I have an Artemis poster here, and Roger is going to tell us all about it. So Roger actually ran an evening course in astronomy over at Hertford, was it Hertford College? And some of the people who were enrolled on that course thought that they'd like to carry on and get to learn more about astronomy. And that's how the society was founded and why it's called the Hertford Astronomy Group, even though we haven't met there for quite a while. So Roger still considers himself an amateur astronomy after, is it 60 years of following the subject? But these days, in particular, the word amateur can be very misleading. And it is in Roger's case, because he's absolutely full of knowledge. He, as our honorary president, he always gives the first presentation to us each year, and he's covered a wide range of topics. So today might have been a review of Artemis 1 on its way to the moon, but in fact, it's going to be a preview because it hasn't flown yet. So Roger's going to tell us all about that. And I trust you can see that I'm wearing my Artemis badge for that. So over to you, Roger.
Yes, Jerry said I'm still an amateur astronomer after 60 years. If you've ever seen me handling a telescope, you'll realise this is a perfectly accurate description. In fact, it's more than 60 years. I worked it out the other day. First time I looked at the night sky where I knew anything about what I was looking at, I would have been about 8. So that is 67 years ago. And I still don't know what I'm looking at, but there you are. You don't have to worry about things like that. The great thing about astronomy, of course, and I think this is why it's so fascinating, is that you don't have to try to do the lot. You can just pick out the bits you like. Although I got told off very firmly by Patrick Moore once. He said, "You really should specialise, Roger." I can't do a good imitation of Patrick Moore. He said, "What are you interested in astronomy?" And I said, "Astronomy." He sort of raised his hands, and then it was my round at the bar, you know. I mean, simple enough, really. Okay, so as Jerry said, I'm going to talk about Artemis. I very carefully prepared my presentations on the basis that I might be doing a yippee, it worked, or an oh dear, it fell in the Atlantic, or it hasn't got launched yet. And it's the third of those that we're going to do. So I'll try and share my screen and we'll see how we get on. Right. Can you all see that?
Yes, we can see that, Roger.
Splendid. Right. Okay. Okay. Artemis, NASA going back to the moon. Well, I hope they get there. We shall have a look at things and see how it goes. Right. I've got a few comments from NASA, or quotes from NASA, some of which I think, frankly, are a bit strange, but there we are. So this is one of their sort of, we will do these things bits. We will land the first woman and the first person of colour on the moon, using innovative technologies to explore more of the lunar surface than ever before. Okay, well, there's nothing particularly exceptional about that. But as any of you who know me will expect, I've got my own views on this. Now, if I were making the choices, I would have an all-female crew. And it would include at least one person of colour. Now, the conventional reason for saying that, and well, I do think there's merit in it, is that the white guys have had their turn. 12 of them have landed on the moon, and another 9 have orbited the moon. In fact, it's more than that, it's 12, isn't it? So, you know, let somebody else have a go. Actually, my real reason for making that suggestion about the crew is simply the publicity value. I think NASA would grab every headline in the world if they chose that crew composition. And they've got enough astronauts that there will be no problem doing it. Okay, so Artemis is not merely aiming, as Apollo did, to get men or people to the moon and bring them back. Artemis is aiming to establish a lunar base. And they're talking about landing at the lunar South Pole because water ice has been discovered there. Some of the deep craters near the lunar poles are deep enough that they are never illuminated by the sun. And in some of them, they think they found evidence of water ice. And of course, the water ice could be melted to make water for people to drink. It could also be electrolyzed to make fuel for rockets and so on. And of course, on the moon, in general, you're not really going to lack power. You know, you've got the sun shining on the moon, and an awful lot of things could be done just by putting up a suitable mirror. If you wanted to make a furnace, for instance, just put up a suitable mirror and concentrate the sunlight onto whatever you want to melt or forge or whatever, and away you go. There is a question here whether the Americans have a right to start plundering the lunar ice, which after all is on the moon, which isn't part of America. Not that you'd know that from talking to some people, but there we are. So there are a few philosophical and legal questions there, but they've got to get there first before they can do any of that. So I think we can shelve that, but just, you know, note that these points exist in the background. And that's not all they're trying to do. They're going to produce a thing called Gateway. Gateway will be a space station in orbit around the moon. And it will be a bit like the International Space Station, but orbiting the moon. It won't be quite as big as the International Space Station. And that's an artist's impression of what it might look like. I suppose I ought to just quickly say that, of course, there is a lot of use of perspective here. The space station is near to you and the moon is a lot further away. They're not planning to build a space station 3,500 miles across. You might think that's a daft comment to make, and it probably is, given the audience I've got here. But some of the comments I've heard on tube trains have left me wondering how much the average person in the tube train has any idea of about such things as gateway space stations. Anyway, it looks like it's quite fun. There's various bits to it, huge solar panel here, and there is an Orion spacecraft nicely docked with it. One of these is I think it's that one, but I wouldn't swear to it. One of these is supposed to be a research area, and the other one is living quarters. I think that's the right way around, but I might well be wrong. And there would also obviously be power units and commercial and communication units and so on. Of course, all of this waits on getting the rockets working. Now, why did they call it Artemis? Well, Artemis is the twin sister of Apollo. So they're sort of trying to suggest that there is a logical progression from Apollo to Artemis. There is a Greek vase, or looks like a coffee mug actually. Probably isn't a coffee mug, they didn't have coffee in them in their days. With Artemis pouring a libation. I always think these captions to archaeological things are quite amusing. You know, just tipping some water over something. Looks like tipping over a dog actually, but there we are. So that's Artemis. There's a musical instrument, a lyre in the background and so on. Now, actually, Apollo and Artemis were supposed to be twins. So there is a picture with Apollo on the left and Artemis on the right. I'm glad I was able to work out which was which and put the captions up, because I don't think I'd have been entirely sure otherwise, but there we are. And there is the Artemis logo, and I presume that is on your badge, is it, Jerry? Good. Okay. So what do we need for Artemis? We need a rocket. And the rocket is known as the SLS, which stands for Space Launch System. And here it is actually on the launch pad after one of the tests that went wrong, and it was about to be taken back to the vehicle assembly building. Is it vehicle or vertical? I can never remember. Anyway, whichever it is, it's going to be taken back there and various tests and so on will be done on it. I rather like the trick of having the, it's a canal in, I think it's the Intracoastal Waterway there. So you've got two rockets for the price of one with a reflection. And you can see the actual launch pad is slightly raised so that the crawler can come back down a very, very modest slope on its way back to take the rocket back to the assembly building. Obviously, none of these things have actually flown. So if you want to know what the Orion spacecraft would look like in orbit, that's what it probably would look like in orbit. What you've got here is a crew module, which is very similar to an Apollo command module, but it is a good deal bigger. It can hold more people and in more comfort. It's all behind there where you can't see it is the equivalent of the Apollo service module, which is, you know, a module with a rocket motor in it, and it's also got these 4 large solar panels. So where the Apollo system derived its energy from fuel cells, this is deriving its energy from the sun. I think really what that shows is the enormous development in solar panels, which are which deliver more power per square meter now than they ever did before, and they're far more reliable. Okay, so the Orion module is designed to carry a crew of 4. Some sources say you could get up to 7 in it. I think describing that as a bit of a squash could be something of an understatement. I think bloody crowded might be nearer. But, you know, there's 50% more room, and they're only designing it for an extra astronaut. There were 3 in the Apollo, and they're going to be 4 as typical crew in Orion. So there will be a bit more room. They will be a little bit more comfortable. Orion has flown without a crew. That was back in 2014 when it performed a highly successful test, which proved that the parachutes worked and so on, and it landed in the ocean and was recovered. So that part, we know it works, which is quite comforting. Now, what we're all waiting for is Artemis 1, and that will be the first flight of the SLS. the first flight of the SLS at all, and it will also be the first flight of the SLS with Orion sticking on top of it. It's a very complex mission, but it won't have any crew aboard. And as I already mentioned, SLS has never flown before. What they call the core stage, the big sort of fuel tank with the engines at the bottom and the two boosters on either side, has never lifted off up till now. So when they finally do light the blue touch paper, this is going to be an extremely nail-biting moment for the NASA people who will be glued to their screens watching it. I must admit, I should be interested to see what happens myself. Incidentally, Jerry mentioned, you know, watching all the Apollo missions. I've always felt slightly guilty about Apollo 13 because I didn't witness the launch and it was the only one that went wrong. So I've always had this feeling that possibly it was my fault. So here is the Artemis mission. You take off from Florida and you fly around the Earth, dropping most of the bits of the rocket as you go. You go forward to translunar injection, which is the point at which the final stage of the SLS ignites and pushes the Orion capsule into a path that will take it towards the moon. It then separates from the ICPS, which is, we'll talk about that a bit more in a minute. And the Orion capsule, having separated from the booster rocket, goes on round here, goes round the moon. This is essentially a gravity-induced path here. There are various trajectory correction maneuvers. It goes around the moon and then goes into a large orbit around the moon. The advantage of this orbit is that essentially it will be, the module will be in sight of the Earth, I think, all the time, which does help a lot. If you remember with the Apollo ones, they used to go behind the moon and then you had to wait for about 40 minutes, as I recall, until they emerged from the other limb of the moon and everyone stopped holding their breath. Mind you, anyone who can hold their breath for 40 minutes has got my admiration. So it'll go around for a few times and then they'll fire the engines. It will do a kind of reverse of the outward path. Slow it down, go round the moon. That will give it a boost and it will then go on a path back to the Earth, go around the back of the Earth and drop into the Atlantic. Assuming this all works faultlessly, the mission will take a fairly long time, and there are other things. For instance, they're going to deploy a considerable number of CubeSats. I've forgotten how many there are actually. There are 10 of them will be deployed. They're deployed off the main rocket, but they will be investigating all sorts of things about the moon. And one of them, which I'll talk to you about in a minute, will actually land on the moon. It'll be the only part of the mission that does land on the moon. Now, this is a completely automatic mission. There's not going to be a crew aboard. So I think you've probably got the idea from this. It's a fairly ambitious project. Now, here were the original launch windows for Artemis 1, August the 29th, September the 2nd, and September the 5th. On August the 29th, they had some problems with fuel leaks, and so they decided they would go for September the 2nd. In fact, it turned out to be September the 3rd. And they were hoping to launch on the 3rd, but They had trouble not only with more fuel leaks, but they also had trouble with engine number 3. Remember, there are 4 engines to this thing. They're very much like the shuttle engines. And they have to be cooled down to the correct temperature, because if you just had them at any old temperature, like sort of ambient temperature on the launch pad, and then you squirted liquid hydrogen and liquid oxygen in, the metal would simply crack. And cracks in the engine are not generally reckoned to be a very good idea. If you can't bring the engine down to the correct temperature, then you can't risk carrying out the launch. Anyway, so they decided to stop the launch, and then go away and work on the engine and work on the leaks and a few other minor problems. So the 5th wasn't even attempted. So that one was scrapped. These are long missions. You know, launch 29th of August, landing back in the sea 10th of October. So that's 42 days. September the 2nd would have been 3 days less. September the 5th would have been back to 42 days. These are very long missions, much longer than anything we're used to. And they involve a lot of testing of hardware and gathering data about the safety of the mission. When the Apollo astronauts went up, people weren't really too sure about whether there was much in the way of risk. All I can remember from that time is that as the rockets passed through the Van Allen belts quickly, it was assumed that, you know, the radiation risk was pretty low. There have been doubts cast on that since. They reckon that some of the Apollo astronauts show signs of having received excessive doses of radiation during the flights. I'm not sufficient of a medical expert to do more than pass that comment on. But anyway, so they'll be doing an awful lot of testing and recording and so on. So let's just look at this mission in a little more detail. So it launches from 39B at Kennedy Space Center. Quite quickly as you go up, I'll show you here, you know, you launch. Shortly afterwards, you jettison the rocket boosters, you jettison the fairings, which join the various bits together and sort of smooth out the shape so it passes through the atmosphere easily. And you also get rid of the launch abort system. This is a small rocket that sits on top of the command module. And if everything went really pear-shaped, they can ignite the launch abort system and drag the command module off the main rocket. And with any luck, it can come down on its parachutes and land safely. Soon after that, the core stage main engine cuts off. So the solid fuel boosters have already gone. Then the core stage main engine cuts off, and everything, the core stage then drops back to the Earth. Then they have what's called a perigee raise maneuver. So they've gone into orbit and they fire the engines of the second stage. And that puts them into a slightly higher orbit. In this orbit, they can then check out what's going on, make sure that the solar panels on the service module have deployed and are providing suitable amounts of power, check that everything else seems to be working. As long as that all works okay, you then come to fire the engines again for translunar injection. That's a long burn, as they call it, about 20 minutes. And this is the one happening here, I think it is. And the eyes have gone. Oh, it's that one there. So the rocket fires, And at number 7 here, it reaches the stage where the interim cryogenic propulsion stage can separate from the Orion capsule. The two of them will go on towards the moon, more or less in convoy, but the command module will be, or the Orion module rather, will be under control, whereas the ICPS won't be. They have to do various trajectory correction maneuvers. That's an incredibly difficult phrase to pronounce. I don't know why. These are generally required just to fine down the path towards the moon and make sure it does everything correctly. And then this number 9 here is called the outbound flyby, powered flyby, which puts them into this path round the moon and then back behind it from the Earth's point of view. And then number 10 here is the lunar orbit insertion. They have to make a small burn and go into orbit around the moon, and it's a retrograde orbit. That is, the moon is going, now I can never get this right, the moon's going in that direction and they're going round there. So the moon is going round like that and they're going round like that. So it's a retrograde orbit. This is an important test because this is one of the orbits that will be used when they actually go for lunar landings and so on. It's called a distant retrograde orbit, DRO. After a while in this distant retrograde orbit, they will return. Now, if I can just bring this down in size, you can see that the ICPS, which has more or less flown in tandem almost with the module, the Orion module, but after that it just flies round the moon and then off. So this is a sort of flyby. So that will get lost, presumably become an orbit, satellite of the sun. So we've got, as I said, round to, I've lost it. There we are, this one. So they've got to then change the orbit and they will depart from that orbit. They go round the moon. This is a return powered flyby. They will have to adjust their speed so they're no longer in orbit around the moon. They'll be going fast enough to escape from the moon and then head off towards the Earth. During that, number 14 here, they will correct their homeward direction. Later on up here, the crew module separates from the support module because the crew module is the only bit that's coming back. Not that there's be a crew in it. And then finally, it enters the Earth's atmosphere and splashes down in the Atlantic. This is, as I say, a very, very complex mission. It's about 40 days in length, which I've already mentioned. It's also going to get a record because this orbit will take it something like 64,000 kilometers beyond the moon. Whether this is strictly necessary or not, I wouldn't like to say. But I do have the feeling that they felt they had to have at least one record in this mission. Anyway, assuming it all goes well, they will splash down in the Atlantic after about 40 days and, or rather not they, the module will splash down in the Atlantic, and that will be the end of a successful mission. This is the an artist's impression of the SLS, the Space Launch System, 2 solid fuel booster rockets, this enormous fuel tank here, and 4 shuttle type engines. Then there's a fairing, and then up here is the ICPS, the interim cryogenic propulsion stage. And then in here is the command module and the service module, and they're all covered by another fairing, which is just streamlining for passing through the atmosphere. That, of course, is an artist's impression. And again, I know I'm harping on this a bit, but this has never been tried. It hasn't lifted off even once yet. So everything depends on whether this bit works. They've done static firings of the 4 main engines, and the boosters have been tested on many flights, so they're all right. But they haven't lifted off before, and I think this is why they're being so very careful. Now, Artemis 1 will actually have a substitute crew of 3. The first one is an adult male-shaped full mannequin, and it's nicknamed Commander Munikin Campos. I must say that reminded me a bit of Boaty McBoatface, but still. And the second one, is a female model torso named Zohar. And the third one is another female model torso, it's only a torso, named Helga. So the 3 of them will be on their way to the moon. We just trust that they behave themselves on this flight. Munikin Campos, well, he's going to sit in the commander's seat. He will wear an Orion Crew Survival System suit, spacesuit in other words. It'd be equipped with radiation sensors and other sensors to record acceleration and vibration data throughout the mission. So they're trying to check that radiation levels are acceptable and that the acceleration and vibration are not such as will pulp a real astronaut in the course of the mission. If you pulp your astronauts, they tend not to work very well. So, you know, it's generally thought that it would be a good idea if they were not pulped by the vibration. It may sound a touch on the flippant side. I don't know whether Jerry or anyone else has been to places like the European Space Agency's testing centre over in Holland. But when you see the vibration that they subject satellites to, you wonder how anything living ever survives. You know, it really is quite terrifying. I mean, much, much worse than what you suffer in an earthquake simulator. So anyway, that's what Munikin Campos is going to do. The mannequin has already been used at the Kennedy Space Center in vibration testing on the Orion seat, which it will occupy throughout the flight. So it's testing vibration and the energy damping system, which is aimed to reduce vibration and to a certain extent reduce the effects of acceleration. So there is Commander Munikin Campos, as he will look like during the flight. Won't be a terribly animated substitute crewman, but there we are. Now, Zohar and Helga have also been called phantoms. I did try and find out why. It may be that it's obvious, but I couldn't work it out, so I'm just passing on that piece of information. But their fundamental job is to support this Matryoshka Astrorad radiation experiment, MER. And that experiment is to provide comprehensive data on radiation levels during these lunar missions to make sure that they are acceptable. What happens if they're not? I'm not entirely sure, because there is no way that conventional radiation shielding could be put round something like the command module, the Orion command module. This is simply too heavy. So, you know, we have to see what they find out. Now, the names, which sounded a bit odd to me, but so I looked them up. Moonikin was chosen by a popular ballot, an email ballot, from a list of names. Campos comes from Arturo Campos. He was the name of a key player in the safe return of the crew of Apollo 13 to Earth. So if I've got this right, he was involved in the lashing together and making it work of the air supply system. If you remember, they were in danger of being choked by carbon dioxide, and Arturo Campos was linked to this and was regarded as a very important man in that. So that's where you get Moonikin Campos. Now, Zophar was named by the Israel Space Agency, and Helga, surprise, surprise, was named by the German Aerospace Center. So there you are. So you've now been introduced to Zophar and Helga and Moonikin Campos. Now, when Artemis 1 is successfully completed, they can start looking at Artemis 2. Artemis 2, which at the moment has a launch target simply of 2023, which I think is satisfactorily vague. And it should be the first human crewed mission to the vicinity of the moon since Apollo 13, which, as Jerry pointed out, is almost 50 years ago now. It should be the first human crewed mission, but I think there is a good deal of worry that the Chinese might pull something out of a hat and either orbit the moon or even, horror of horrors, land some Chinese astronauts on the moon. They might even get round to bringing them back. And I think this is one of the things they're really worried about. The Chinese have a very good record recently of missions. After all, they've sent a lunar sample return mission to the moon. It landed in the Mare Imbrium and brought back some rock samples. And they've also had the first lander on the moon that landed on the far side of the moon. And that also deployed a ground penetration radar, which has not turned up anything very startling in the way of results. But nevertheless, it was two firsts, the first ground penetration radar and the first landing on the far side of the moon. Obviously, the Chinese have also had a number of orbital flights, including one woman. So the possibility that the Chinese might land on the moon definitely exists. And I think they are desperately hoping to get Artemis 2 up and running before the Chinese steal all the glory. Artemis 2 is technically slightly less ambitious, as it says there, than Apollo 8. Apollo 8 flew to the moon in December 1968, and it orbited the moon 10 times. Then it returned to the Earth. Artemis will go round the moon and come back to the Earth. The crew will not be in orbit. I couldn't resist putting in, I think this has to be one of the great iconic pictures of 20th century, Apollo 8 orbiting the moon, and there is the Earth, beautiful blue seas, white clouds, lovely planet rising above the moon. And as you can see, the moon is pretty desolate. In fact, that image rather makes the moon look nicer than it really is, because the colours of the moon are essentially charcoal grey, black, and Bourneville chocolate. It's very dark. One of the Apollo astronauts, in an unguarded moment, actually said that the surface was pretty boring to look at because it was basically black or nearly black wherever you looked. Okay, so that's a bit of history and what they're trying to do. Artemis 2 will have to stay in Earth orbit for quite a long time. They have an enormous amount of checking to do. Then Orion will take its crew to the moon and on what's called a free return trajectory and come back to the Earth. So the Orion capsule with 4 people on board, sorry. So one more than the whatever they're called, the mannequins or whatever, one more than them will go around the moon, return to the Earth and splash down in the Atlantic. And here is the similar thing showing the Artemis 2, launched from Florida, goes around the Earth, ditches the core stage, the ICPS and so on. Sorry, I'm doing this the wrong way around. This is the right way around here. So it flies out towards the moon, goes around the back of the moon. Notice this is just the Orion module. They've cut down the detail in this one. And then it will fly back from where we're looking, go around the back of the Earth, and will re-enter the Earth's atmosphere to drop in the Atlantic Ocean. It's a much simpler mission than a lander, and simpler even than a lunar orbiter. So as I said, if you think of Apollo 8, Apollo 8 went to the moon, used its engines to go into a quite low orbit around the moon 10 times, then fired its engines again and came home. So this is an all-important first step for the NASA aim to go back to the moon. But it's not quite as ambitious as NASA is hyping it up to look. Nevertheless, I hope it works. So there is a nice picture of the Artemis stack arriving at the launch pad with a nice little caption under the bottom there, "We are going." The only trouble is they won't. And there you are, that's when it got there. So it was 17th of August, aiming for a launch on the 29th. So it's rolled out there. Now, one of the things that will be on the way to the moon, this is in Artemis 1, is this outstanding, I can't get this to show it, it's got a silly acronym, Outstanding Moon Exploration Technologies Demonstrated by Nano Semi-Hard Impactor. As usual, this is a fairly tortuous acronym. The word in Japanese apparently means welcome. It's a CubeSat. CubeSats are small, as it says there, autonomous spacecraft. This one is about the size of a small suitcase, sort of thing you use for a weekend away. Oh, there we are, Omotenashi. And there is an artist's impression. Omotenashi would be falling towards the moon. This is entirely automated. It has a little rocket motor which will bring it to a halt. It will then inflate these two sort of dumbbell things and drop to the surface of the moon. So it will be brought to rest by its rocket motors 100 meters above the lunar surface. The rocket motors will be switched off and it will drop to the moon and land. That's why it's called semi-hard. And the impact will be broken by inflated balloons. I have to say, when, what was the name of it? It became the Carl Sagan Memorial mission thing on Mars. Anyway, whatever that was called, when that landed on Mars and they said it was going to bounce on these inflated balloons and roll across the surface, I thought, you know, pull the other one, it's got bells on. And I was delighted to be proved wrong. It actually was a highly successful means of landing stuff on Mars, and was repeated for Opportunity and what was the other one? I can't remember now. Spirit, wasn't it? Spirit and Opportunity. They both landed the same way. And of course, that's how Beagle was supposed to land, but Beagle's panels didn't open up. Okay, so it's got two objectives. One is to land on the lunar surface with all control and communication systems working. And the other one is to make detailed measurements of the radiation environment before, during, and after the landing. So this is quite a useful, small scientific experiment. These CubeSats, I mean, it sounds quite expensive to you and me. They cost just a few million quid, but compared with the cost of any major expedition, they're almost small change, you know. Deprive the workers of 2 coffee breaks and you've got enough to make a CubeSat. Now, all of these CubeSats, remember there are 10 of them, they will ride inside what is called the Orion Stage Adapter, which sits between the ICPS and the Orion modules. And the CubeSats will be deployed from there once the Orion module is a safe distance away. This, by the way, is safe for the Orion module. You know, if one of the CubeSats was wrecked by bashing into the Orion module, nobody would worry very much. But if the Orion module was wrecked by being bashed into by a CubeSat, they would worry about it. So this is what they call the core stage, the big fuel tank with the rocket engines at the bottom. There's the 2 solid fuel rocket boosters. This is the interim cryogenic propulsion stage, which is here. There's the fairing that it sits in. And this is the adapter between the Orion stage and the ICPS. And that's where the CubeSats will be deployed from. Okay, so usually CubeSats are limited to low Earth orbit. This is a chance to chuck them out into cislunar space, which is quite something new. So here's another quote from NASA. Although they may come in small packages, the science and technology investigations enabled by these CubeSats will help play a role in paving the way for future human exploration in deep space, including the journey to Mars. Personally, I think they've got to get them to the moon first. I'm not really bothered about the journey to Mars yet. There's so many problems about that, which they're tending to somewhat gloss over, I think. Okay. SLS, again, this is a quote, has the capacity to carry crew and cargo for deep space exploration missions, including the journey to Mars. See, they're really pushing this. And so the small satellites are piggybacking on this SLS flight. So they'll reach their deep space. Now, Artemis 1 did not take off on the 29th of August. They had the problem with the engine, they had the problem with the fuel leak. So they then tried again on the 2nd of September and began another countdown. The 2-hour launch window was open at 2:17 p.m. This is Eastern Daylight Time in America. And there was a hydrogen fuel leak. I think they still failed to cool engine 3 properly. So that was that. Now, this is my interpretation. I may be wrong. I got the impression from some of the bulletins that they might have been prepared to work round the fuel leak because they could minimize it by using various tanks and so on. But the engine problem was the killer. In any case, they decided to abandon the launch, and they've now announced that the next test flight will not be before the 27th of September. This is the new formula they always use, will not be before the 27th of September, thus allowing for a few problems in the countdown and so on. The launch window is only 70 minutes, which isn't a lot. So if they fail to meet that launch window, then there is a backup launch window on the 2nd of October. And there is a nice sunset picture of SLS with ICPS and Orion on top of it, sitting there in Florida and hopefully waiting to be launched at the end of this month. So that's the Artemis mission. I don't know how we're doing. Alan, how are we doing for time?
If you could wind up in about the next 5 to 10 minutes, that'd be good.
Okay. Well, I won't do the SLS then. We talked about the SLS quite a bit. So let's talk about the Orion thing, which, oh God. So I'm going to share the screen again. Can you see that?
Yes, we can see that.
Right. Okay. So this is the Orion capsule to take a crew to the moon and, more important, bring it back. Artist's impression of Orion in action. This is the crew module. This is the service module, and these are the solar panels generating the power. We've all done that. Crew of 4, a bit bigger than the Apollo command module, and it has been tested. There's some detail. You can see that the crew module is bigger than the Apollo module, but you can also see that the service module is certainly no bigger than the Apollo. This is the service module for Orion. It's no bigger than the Apollo module. And in fact, it's not as powerful as the Apollo service module was. Don't forget that these are different missions. But one does get a certain impression of the this being somewhat cobbled together. There's a picture of the pressure vessel, which is actually the thing which contains the air, which will enable the crew to breathe. There is the heat shield, which of course will protect the module on its way back into the Earth through re-entry. This is the basic heat shield, but there is a cover which will be put on it, and then the whole thing will be installed on the base of the crew module. There's Orion in space. This is an artist's impression. So you can see solar panels, and there's one hidden behind there. And there's just the names of all the different bits. Now, it sits on top of the SLS. In here is the interim cryogenic propulsion stage, which is essentially an adaptation from the second stage of a Delta heavy vehicle. And to be honest, I think it's simply not powerful enough. This is why there is a serious limit on the amount of tonnage they can get to the moon. Although this rocket is actually more powerful than a Saturn V, it can't take as much stuff to the moon as a Saturn V could. So here again is the service module, there's the command module, and there is the launch abort system, which sits on top, and it's got small rocket engines there. If something goes dreadfully wrong, the launch abort system can pull the command module off the stack and hopefully pull it away. So if all this lot is going to crash or blow up or whatever, it is hoped that this can pull them away and they can then come down on their parachutes and be safe. This has never actually been tested in an emergency, but they have tested it with dummies and so on many years ago, and it seems to work. So there we are. The service module is interesting. The European Space Agency built what they call the automated transfer vehicle, which was used with the space station and could actually deliver far more supplies to the space station than a Russian Progress rocket could. I've been wondering what had happened to it, because it just seemed to have dropped out of sight. Nobody seemed to be using it or whatever. Anyway, essentially, the Orion service module is an automated transfer vehicle modified. And there you see an automated transfer vehicle. This bit, as you can see with these angled solar panels, this is the rocket part and this is the cargo part. So this is the bit that's got all the power, and instead of having a cargo pod on the front, it will have an Orion command module. There's 4 astronauts in a mock-up of the interior of an Orion module. You see they've got considerably more room than they had in an Apollo command module. There's the 3 current capsules compared. There's an Apollo, there's the Orion, which is quite a lot bigger, and there's the Dragon, the Crew Dragon SpaceX module. There you see the 2 systems. There's the launch escape system from Apollo. There's the launch abort system from Orion. And you can see rockets, the bigger module and so on. Now, of course, Apollo astronauts wore nappies, which weren't very popular, but that was what they had to do. And after use, they had to put them in disposal bags, which they had to seal up with sticky tape. Self-sealing bags had not been invented in their days. And the waste disposal bags were stored in a bay in the command module. Apparently, these bags were not entirely airtight. If you've ever seen the face of the frogman who opened the hatch of an Apollo command module after it had landed, it was quite clear that the air that came out was not exactly fresh. Now, they're going to boldly go in Orion. They've got their own toilet. This is it looks like a highly modified version of the one that it sort of crushed down, made smaller, but essentially I think it's very similar to the one on the International Space Station. And it will be put in a little cubicle, so you even get some privacy. I think this is actually a considerable advance. I think if you ask the crew, they would probably say, you know, this is quite an important improvement. And they go into a thing called a near rectilinear halo orbit. It goes around the moon. It's an elliptical orbit, but it's sufficiently fat that it could be, it's not too far from a rectangle. And the advantage is that the spacecraft can be kept in constant contact with mission control. I saw Jerry nod when I said before about the nail biting bit when the Apollo astronauts went behind the moon and went out of contact. So it never actually goes behind the moon as seen from the vantage point of the Earth. The halo orbit is quite big. They're only 3,000 kilometers from the moon at closest and 70,000 kilometers from the moon at furthest. It goes over the North and South poles, but it's very close to the North Pole and very far from the South Pole. So in an orbit like that, it will spend most of its time here and whiz round the moon. The orbital period is 6 to 8 days, whereas of course the Apollo orbits are about 2 hours. And this is a picture taken by an automated camera in the Orion capsule, looking at the Earth, looking beautiful and blue and white as usual. And that was on the 5th of December 2014. The parachutes worked. Good thing, you know. It means you can land in the sea safely. And there it is, floating in the sea, having come safely back. And the next time we see this picture, or a picture like it, that should be a capsule that has gone round the moon. And the time after that should be a capsule with a crew in it that has also gone round the moon. So there are a few things to point out here. Orion is described as being able to go further and stay longer and all this business. But it's essentially an enlarged Apollo command module. And although it's bigger, it's carrying more crew. It can operate independently for 21 days, which is roughly twice the longest Apollo flight. But before we start getting too excited, a journey to Mars would take at least 250 days. In fact, more than that. So, you know, 21 days is a good first step, but it's only a first step. We're not there yet. We're not on the way to Mars, whatever they say. So that I think is enough from me. If you have any questions, and if we've got any time, Jerry will presumably throw them at me.
Thank you very, very much indeed, Roger. Very detailed presentation. And we do have some questions that have come in already. So first one is, why is it taking Artemis 8 days to reach the moon when Apollo took 3?
Basically, I did have a presentation for this, but it took long. Everything took longer than I expected. Although the Space Launch System is, in terms of sheer power of the rockets, more powerful, it's also heavier. And it simply doesn't impart so much speed. And the ICPS, the interim cryogenic propulsion stage, is, by my estimation, somewhat underpowered, and it simply cannot provide enough oomph to get the module to the moon more quickly. There is another Space Launch System second stage in preparation, but so far as I know, well, I know it has not been loaded on top of a core stage and tried yet. So we'll have to wait and see how that does, but that will enable considerably more tonnage to be got to the moon. In terms of doing what Artemis is supposed to do, being able to get the tonnage to the moon is more important than speed.
Okay. Right, next one. Just like with the shuttle, are the solid rocket boosters reusable?
Well, if you manage to find them, yes. In practice, generally speaking, it's not likely they're going to be able to reuse the boosters. And these boosters are bigger. They have 5 decks instead of 4. And that means that they are structurally stronger than the shuttle boosters. But that also probably means that they'll hit the sea harder. So I doubt if there's going to be much reuse. They might be lucky. I mean, you know, one of them might actually land on a ship and, you know, just be brought back. But, I mean, there's no plan to do an Elon Musk and land the boosters back on the launch pad. So no.
To do that, you need to hold fuel on it.
Yeah,
and
precisely.
you can't do with solid rocket engines anyway. But
Exactly.
also, they are longer than the shuttle solid rocket boosters. They'll be heavier once all the fuel has been used up, which will mean larger parachute and everything, and that increases the mass which they prefer to use in just providing thrust. So
I don't think they actually carry parachutes, do they? I'm not sure.
I don't think that these ones are. They're not intended to be reused. No. The second part of this question is the Orion capsule reusable, or is it single use only? And there the answer is yes, it is. Well, that is the crew module is reused, but the will get burnt up.
I mean, in theory, that was also true of the Apollo command modules, but they never did reuse them.
Yeah.
Any more?
Right, next one. Comment, at last, a Portaloo in space. I hope it is unisex. Well, yes, because
yes, they're a bit coy about you know, how both sexes will be able to use it, but yes, they are designed to be used by men and women.
Yes.
And anybody else you might care to send, you know, I mean.
Yeah, okay. Is there a long-term plan from NASA for larger moon vehicles for when the USA start mining the moon, as the SLS seems too small for that? Well, no, you just send out.
My theory, sorry, not my theory. My reading of this is that if they start mining the moon, they will mine it. Well, the first thing they'll mine it for is water ice, and that will be used on the moon. And the idea is that if they build a base, they will build it out of indigenous materials. And after all, the moon is made of rock, so it, you know, if you wanted to build a base, it should be fairly easy to obtain chunks of rock and build your base. Also, the lunar surface environment is pretty awful. You know, there's no air. You've got solar wind and solar radiation pouring all over you. So in essence, the base will effectively be underground. So they'll have to tunnel down and then build some kind of igloo over the top of the entrance and so on. So I'm not aware of any plans, certainly not at this stage, to export material from the moon to the Earth. If you want to read some interesting stuff about that, read Robert Heinlein's novel, The Moon is a Harsh Mistress, which is quite entertaining, as Heinlein's books usually are, but he's got some quite interesting ideas.
Yeah, okay. I'm just looking through some of the notes that I've made during your presentation, which are actually fairly extensive. I'm pleased to say. So, oh yeah, one reason that the service module is going to use solar panels is a lesson learned from Apollo 13. Having lost the fuel cells, they didn't have any means of power other than the batteries in the lunar module. So this way they won't have to rely on anything like that. As long as they can see the sun, they should be okay. So you mentioned about the fact that this is going to be the first flight of the Space Launch System, although obviously we have to acknowledge that it is based on the Space Shuttle. In that there's the core section which fed the main engines, which were actually on the shuttle orbiter, and the two solid rocket boosters. But when that was first flown, and its first flight was a manned mission, STS-1, that had never flown before. And that also didn't fly the first time it was supposed to, which was April the 10th, 1981. So there was a 2-day delay. So it was pure coincidence that it actually had its first launch 20 years to the day since Gagarin went on.
Oh, of course, yeah.
Oh yeah, yes. So the crew that Artemis is going to have, it's mannequins. Not the first mannequins to go into space. The Russians launched one in prototype Vostok before Gagarin went up. But more recently, when SpaceX a couple of years ago launched the Falcon Heavy, which is effectively 3 Falcon 9s side by side, because it was the first flight of that vehicle, they weren't going to risk anybody's multi-million-dollar satellite on it, but they did need some kind of mass at the top. And so one of the things that was included in there was something else from Elon Musk. So not only does he own SpaceX, but he also owns Tesla. So they actually put one of his Tesla Roadsters on the top of the rocket, and that was sent off on a big outward orbit that actually took it past the orbit of Mars. And there was a dummy in the driving seat. So when I was interviewed on BBC about this, I pointed out that because of this, it's going where no mannequin has gone before.
Oh dear.
It took photos automatically during its journey, and one photo was a sort of selfie of the car, showed the Earth in the background, and you can see Australia on there as it zoomed out in space. And so one somewhat enterprising Australian police force issued Tesla with a speeding ticket.
Quite a good looking question just came up there. I didn't manage to read all of it. Something about a lander.
Yeah, will the first Artemis moon landings be using a similar vehicle to the Apollo lunar module? Well, it depends who they actually choose to provide the vehicle, doesn't it?
Very much so. I mean, it's a different technique. I mean, the Apollo took the whole shebang. You had the command module, the service module, and the lunar lander all sitting on top of the Saturn V. But the current Artemis idea is that you will have 2 launches, and that the lunar lander and the command module will rendezvous in lunar orbit.
Yes.
The lunar lander is likely to be somewhat like an Apollo lunar lander, but a good deal bigger and more powerful, but essentially, 4 sprung legs with a rocket, and probably with a detachable base, so that the bit that goes back to orbit gets launched from something, which can be adjusted and leveled and all that kind of thing. It's quite a bigger idea, but I mean, it isn't available yet. I mean, Jerry is quite right. I don't think they've even decided which of the contending designs they're going to go for. They better hurry up. If they're hoping to land on the moon in 2024 or 2025, they better get a bloody move on, as far as I can see.
I know ideally what they'd like is a lunar lander that will recycle between the surface and the gateway in orbit around the moon. And so that will go up and down like that, refueling. And the crew will go out using the crew module from Earth and back. I mean, it is more complex that way, but more efficient long term if they can put that out. Okay, well, I think that we'll need to call things to an end. Thank you, everyone, for your questions. And especially thank you, Roger, for going into such detail with this. But whilst doing so, making it all understandable to everyone. So thank you very much.
Well, thank you all for listening. And thank you, Jerry, for handling the questions. And so I suppose it's over to Alan now.
Okay, well, thank you very much indeed, Roger. Like Jerry said, you made it so understandable, and that takes us back to when our association started, with people coming along to evening class and learning right from the beginning. And because you made it so understandable, we were able to continue and form this club. So thank you very much indeed for all the groundwork and all the knowledge you've imparted to us over the years. Long may they continue. So thank you very much indeed.
Well, thank you, Alan, and thank you all. I am immensely proud of my association with the Hertford Astronomy Group. And I mean, they totally surpassed anything I had anything to do with. I mean, I just sort of come along and say hi and give you a talk occasionally. What you've done is terrific, and well done, absolutely brilliant. Okay, well, that's me done for the moment. While I was making my coffee, I discovered that I had a tin of pills in my fridge. So I will leave you to have a chat amongst yourselves, and I shall go and extract my tin of pills from the fridge and lubricate my throat accordingly. So thank you very much to everybody, and I will say good night.
Okay, thank you very much, Roger. Good night, and we look forward to seeing you again in the future.
Okay, I'll look forward to it too. Good night.
Good night then. Okay, well, that's bringing us to the end of the meeting tonight. So just a couple of announcements to make to you. Just to remind you, if the sky is still clear and you want to get outside and see Uranus reappear on the other side of the moon, then you've still got plenty of time to do it. I'd like to draw attention to some interesting kit that's for sale. We have a web page called Bring and Buy, where people who can bear to part with their kit can advertise it for nothing. And there are some pretty incredible offers on there at the moment. There's a really lovely mount on there. There's a very nice 130mm Celestron reflector telescope on a go-to system. And there's a small grab-and-go Celestron telescope as well. That one needs some eyepieces, but the prices that the people are offering them for are incredible. A couple of them actually have just said that they're going to give the money to a charity. So if you want to have a look at them, you're very welcome. And also, if you've got some kit of your own, and I'm sure many of us have got a few spare eyepieces, possibly telescopes, tripods, and all that other stuff, which might come in useful one day, perhaps this is the day that you can make it even more useful. A reminder that our next full meeting is on the 12th of October. We've got Richard Westwood coming along to talk about solar eclipses. Now, we are hoping that we'll be able to transmit this as a Zoom and have it as a live meeting from the university. We ask you just keep an eye on what's going on. We try to keep you informed if things don't work out quite as expected, but there was a combination of things happened that made this meeting become Zoom only. I won't go into them, we haven't got time. But we look forward to seeing you on the 12th of October, because following that, on the 25th of October, there's a partial solar eclipse. Again, we are hoping to run some sort of public event on that. At the moment, details to be confirmed, but put the date in your diary. It's going to be a morning event, and we'll keep you up to date with that. Other than that, all I'd like to do is say thank you very much indeed to all of you for coming along this evening. It's been lovely seeing you. And like I said at the beginning, if you are new to us, do hang around and say hello to us. I'm going to formally end the meeting here, stop the recording, but I'm not going to turn off. And I'm in control tonight, so you're not all going to suddenly disappear like we have done on some of the previous occasions. So thank you and good night officially.
Thank you, Alan.